All right, how are we doing today, guys? Today we're going to be talking about dividing decimals by whole numbers, and we're also going to be using estimating. I'm a huge fan of estimating. I think it always helps us check our answers on the fly, because sometimes you don't want to put in the effort to really write down or double check an answer, or if you're dividing, you don't want to double check with multiplication. You want like a kind of a quick little way, and then you can keep moving on. Estimating is a great way to do that all the time with only spending a few seconds. So we're going to be talking about estimating as well. When you divide decimal numbers, or numbers with decimals, by a whole number, you will essentially use the same long division algorithm, but what you're going to do is you're going to keep that decimal point in mind as you divide. So I'll talk about that while we solve this first one here. So we have 37 and 8/10 divided by 3. So let's estimate first. How can I turn this into an equation that's just kind of easy to solve? I'm going to say, well, 37 and 8/10, that's close to 36. So I'm going to say, I'll write it down here in the bottom. Say 36 divided by 3. Well, that's 12. So I'm going to say my answer is probably close to 12. Let's check on that. So 3 goes into 3 one time. And then we have 0, bring down the 7. 3 goes into 7 twice. 6 minus 1. Then I'm going to continue past the decimal because there's an 8 back here. I'm going to bring it down. I'm going to say 18. 3 goes into 18 how many times? 6. Now, if I want my answer to be close to 12, I'm going to put that decimal point directly above. And you're going to see that that's a theme, is the decimal point will always rise up to where it was, which means it's important that, I'm going to switch on my highlighter color here, it's important that when you place these numbers, so 1, it's important that you're saying 3 goes into 3 one time, and 3 goes into 7 2 times. So it's important that you're lining everything up, right? And when we got down to here to 18, 3 goes into 18 6 times. So everything needs to line up. If things don't line up and you bring that decimal point up, it's not going to work out so well for you. Okay? So moving on to the next one here. 7 and 24 hundredths divided by 5. How can I turn that into something really quick for me to solve and estimate with? Well, I could do just 5 divided by 5. Let's say that's 1, and that'd be a low estimate, right? Because I'm rounding 7 down. What if I round 7 up to 10 and I say 10 divided by 5 equals 2? I say, okay, well, if I rounded it down in this one and I rounded it up in this one, I'm going to say my answer should be in between my estimates. So my answer is going to be between 1 and 2. All right, so let's solve this and check that out. So 5 goes into 7 one time. Okay, there's my 1 already, right? So that'll be 5. Subtract 2, bring down the 2. 5 goes into 22 4 times. Okay. 5 goes into 24 how many times? Say 4 again. Okay, so I've made my way past the decimal point. 20. Now, here is where things will be a little bit different. Now, I've brought down, I brought down this 4 here. And so I have 4, so you could say, okay, so a common mistake is students will say, well, 1 and 44 hundredths, and then remainder 4, right? They'll say that's the remainder. Well, I am here today to tell you that because we are dividing decimals, you want a decimal answer. You don't want to be left with a remainder and a decimal, because technically this 44 hundredths, that's not a whole number, so that's kind of part of your remainder already, right? When you get a remainder, that's just not a whole amount of times that 5 goes into it. So we're saying that 5 can go into 7 and 24 hundredths one whole time, and then 44 hundredths of a time, and then some more, because there's this 4 down here. So I'm going to say, I'm going to let you know, and I think you know this, just like when we subtract decimals, you can put zeros as placeholders. We know that there's zeros that continually go on and on and on, right? And we're not going to use all of them, but we've got kind of these zeros in our back pocket to use. So I'm going to put this 0 here. I'm going to say I can now bring down that 0 and say 5 goes into 40 how many times? 8. And look at that, it wraps it up just like that, 0. And this becomes my answer now. And once again, I can see that I lined everything up, and so that means that in the end, when I put my decimal point just went straight up, or at least kind of straight. I guess it's a little crooked, but anyway. So I got my answer here. I'm going to try and get some of this highlighter out of the way without erasing everything. And I just want to see, does my answer actually line up with, let's see, can I get rid of this highlighter? I don't know, it's not working with me. Does my answer line up with my estimate? And I'm saying, I think it does. 1 and 448 thousandths is definitely almost actually right in the middle of 1 and 2 down here. So my estimate says it's right based on what I know about moving the decimal point up. I'm also saying it's right. So let's move on to the next one here, and let's keep this idea of putting this 0 on the end, right? That's kind of the new thing from that equation, is putting that 0 on the end. We want to keep that in mind. We've got that in our back pocket. All right, over here, 8 and 52 hundredths divided by 4. So I'm saying that's about 8 divided by 4. So my answer should be about 2. I think that's a pretty straightforward one. Let's go at it. 4 goes into 8 2 times. Okay, 0. Bring down the 5. 4 goes into 5 1 time. Bring down the 2. 4 goes into 12 3 times. 0. And that wraps that up. Now, where can I put the, let's fix this too. Where can I put the decimal point to make it near my estimate? Right above the decimal point that's already down here, right? Move it straight up. And we've already talked about how that's working for us, and looks like it worked good this time too. Let's move on to our last one here. 30 and 1/10 divided by 7. Okay, let's estimate really quick. I'm going to say 30, I'm going to round that down to 28 divided by 7. So my answer should be close to 4. Okay, so notice I'm not rounding to the tens place, by the way. I'm not rounding to the tens place every time. I'm not rounding to the ones place every time. I'm not even necessarily thinking about front end estimation, right? Rounding to the farthest left number. I'm just thinking about how can I turn this number into a number that could be easily divided by my divisor so that I can just solve it in my head really quick. Maybe you're the type of person who's going to say, oh, 7 actually is close to 6, and I could do 30 divided by 6 and get 5, which is actually close to 4. So that's fine too, just another way to think about it. When it comes to estimating, I'm going to say as long as what you're doing gets you reasonable estimates to justify your answers, that's fine. That's fine by me. That works. So let's actually solve this thing now. 7 goes into 3. It does not, right? So I'm just going to put an X above it and say, nope. 7 goes into 30. How many times? I'm going to say 4. 28. 2. Bring down the 1. 7 goes into 21 3 times. And that is that. 0. Wrap it up. I'm going to bring the decimal point up to 4 3/10, and that's really close to 4. And that's that. Okay, so that's all for today's lesson. I think it's definitely a good thing to keep in mind our little 0 over here, right, that we went over. That is a really important thing, because it's not every time that you'll get nice answers that kind of wrap it up quickly like the other 3 examples. You might want to tag zeros onto the end if you find yourself putting a remainder, because there's no remainder when you're dividing decimals. Okay, that's the whole point of getting a decimal answer. So that's all for today's video. If you have any questions or comments, post them below, and thanks for watching.